Okay, we're ready to look at our next technique of integration, trigonometric substitution. But we're going to start off talking about a little bit of review from trig and algebra that we use in this section. So we're going to look at remind ourselves of some right triangle trig, right? So if we have a right triangle whose sides are A, B, and C, and we'll say that angle is theta. One thing we know from algebra is that a squared plus b squared equals c squared, right? So we can solve for each one of these in terms of the other, right? So a can be written as c squared minus b squared. B can be written as c squared minus a squared. And c, well, we already know what that is. That's the square root of a squared plus b squared. Okay, we're going to need that in this section. Okay, so also remember that if you have a triangle, let's write it right here. We'll say A, B, again, A, B, and C, angle theta, a right triangle, that you can pull off the trig functions, the 6 trig functions from this right triangle, right? So remember that sine of theta is going to be the opposite over the hypotenuse. So in this picture, B over C. Cosine of theta is going to be adjacent over hypotenuse, or A over C. And then tangent of theta is opposite over adjacent, or B over A. Okay? And then the reciprocal functions we get from the right triangle, or we can just realize that we can, flip them. Secant of theta is C over B. I'm sorry, that was cosecant. Secant of theta is C over A, and cotangent of theta is A over B. So we can get all that from this right triangle. In a similar way, if I gave you the relationship of one of these 6 trig functions, you should be able to generate a right triangle that has those features. So what do I mean by that? Let's say we had the sine of theta was, I'm going to say x over r. All right? Well, what this tells me is that I can create this triangle. So remember that sine is opposite over hypotenuse, so it has the ratio of x over r. That's angle theta. All right, now using our Pythagorean theorem, that means this side right here, in terms of x and r, is r squared minus x squared. And so now using this triangle, we could generate the other 5 trig functions. What if I said tangent of theta is, we'll say x over a? Well, let's draw that picture. So we know the ratio, that tangent is opposite over adjacent, so we could create this triangle that has that ratio for tangent. And that would mean this side right here is a squared plus x squared. Or maybe I say that secant of theta is x over a. All right, so what does that mean? That means, well, remember, secant of theta is the hypotenuse over the adjacent. So that would be x over a here, and then this side would be x squared minus a squared. Okay, well, that's the angle theta, and that's a right triangle. So we're going to definitely need to use these ideas in this section. All right, another review that we want to talk about is a little bit of review of inverse functions, and in particular, the trig functions, right? So a couple things to note, that only one-to-one functions have inverses. And remember, that means they pass the horizontal line test. What else is true? The domain of f equals the range of its inverse, and similarly, the range of f equals the domain of f inverse, assuming that the the inverse exists. And another thing is that if you compose a function with its inverse, you get back the input, and that's true in either direction. And that definitely comes up in calculus. All right, so we have talked before about inverse trig functions, but we also know that trig functions are not one-to-one, right? They're not one-to-one on their domain. So when we are discussing inverse trig functions, we are doing that on restricted domains. So if I said f of x is equal to sine of x from negative pi over 2 to pi over 2, that's the standard restriction when talking about sine and its inverse. It spans the entire range of sine, but is also one-to-one. So that's negative pi over 2 to pi over 2. This function is one-to-one and has an inverse. So this is the domain. And as you can see, the range is negative 1-to-1, right? Spans the entire range of original sine. Okay, this function has an inverse. So f inverse of x, we denote sine inverse of x, or arcsine. That's another way to write it, arcsine of x. And its domain is the range of the original, so negative 1-to-1, and its range is the domain of f, which is negative pi over 2 to pi over 2. All right. Let's look at cosine. So f of x equals cosine also is not a one-to-one function, but if we restrict it to 0 to pi, so that's our domain here, and the range here is negative 1-to-1, and it looks like this. So we see that it spans the entire range of cosine, but is restricted and in such a way that it is a one-to-one function. This function has an inverse, and we denote it cosine inverse of x or arc cosine of x. Its domain is the range of f, which is negative 1-to-1, and its range is 0 to pi. Okay? And lastly, let's look, well, we're not going to have room for that, but we'll just come down here and I'll do it on the side here, that if we want to talk about tangent of x, that also is not 1-to-1 unless we restrict the domain, and the standard restriction is negative pi over 2 to pi over 2, but not including the endpoints because those are asymptotes for tangent, right? It's undefined there. It's where cosine is 0. That is a 1-to-1 function that's the domain for this restriction. And its range is all real numbers. So this function has an inverse, which we denote tangent inverse or arctan. And its domain is the range of f, so negative infinity to infinity, and its range is the domain of f, which is negative pi over 2 to pi over 2. Okay, these things are going to be useful to us in our next videos where we start looking at integrals where we want to apply trig substitution.